Welcome to The Explainer. Today we're diving into something you probably don't think about much: hazardous lab waste. We're going to look at what happens to chemicals after they're used, and believe me, it involves some pretty strict rules, surprising dangers, and frankly, some staggering costs. All right, to kick things off, let's look at a pretty wild example. You've got regular old table salt. Totally harmless, right? But what happens if you dump a ton of it down the drain? Well, it ends up in our waterways and can do serious damage to wildlife, like the Pacific salmon you see here. And that right there is the whole point. How dangerous something isn't just about us. It's about its impact on the whole environment.
So this really gets you thinking, right? When does a perfectly normal chemical cross the line and officially become hazardous waste?
What's really interesting is that a chemical doesn't have to be, super toxic to be considered waste. Sure, being too hazardous is a big one, but it could also just be that you have way too much of it, it's expired, the bottle's falling apart, or you just plain don't need it anymore.
And this bottle right here? It is the perfect example of what we're talking about. I mean, look at it. The label's a mess, the container's stained. Even if the chlorine water inside was useful at one point, its age and the state it's in have turned it into a real liability. It's officially hazardous waste.
Okay, so we've got all these different ways chemicals can go bad. But when you think about all the reactive, corrosive, and toxic stuff in a lab, which one poses the single biggest threat?
The answer? Well, it's probably not what you're thinking. Go on, take a guess. What do you think is the absolute most hazardous thing you could possibly find in a lab?
It's this simple. The most dangerous thing is the one you can't identify. An unlabeled bottle is a massive risk. Why? Because if you don't know what it is, you can't know if it's going to explode, catch fire, poison you, or if it's just water. You have to treat it like it's the worst-case scenario.
And that danger of the unknown brings us to the next big piece of this puzzle: the unbelievable cost of getting rid of this stuff the right way.
I mean, it's not like you can just toss this stuff in the garbage can. There are super strict state and local laws for every single step. You can't pour it down the sink, throw it in the trash, or dump it outside. It's a very controlled process for a very good reason: to protect all of us and the environment.
And all that control, it gets expensive. Get this, properly disposing of a chemical can cost up to 500 times what you paid for it in the first place. Let that sink in for a second. 500 times the purchase price just to get rid of it. It's staggering.
So what's driving that insane price tag? Well, it all comes back to our number one villain: the unknown substance. When a disposal company finds an unlabeled bottle, they can't just take it. They have to run a bunch of expensive, time-consuming tests to figure out what's inside, even if it turns out to be something totally harmless like salt water.
Okay, so the stakes are super high, right? The danger, the cost. How do places like schools even begin to manage all this correctly?
Well, it's basically a tag team effort. Teachers are kind of the first responders. They slap a red dot on waste, make sure every container has a label, and store it safely. Then they call in the district's chemical hygiene officer, or CHO. The CHO inventories everything, deals with a low to medium risk stuff, and then calls in the pros for the really nasty high-hazard waste.
Now, for some of the more common stuff, there are actually specific playbooks. Let's say you have small amounts of simple acids or bases. You can actually neutralize them right there on site to a safe pH, which makes them safe to go down the drain. But you can't just wing it. It takes careful procedures and a detailed log of everything you do.
But what about stuff you absolutely can't put down the drain, like solutions with metal salts? That's a whole different game. The goal there is to concentrate the waste. You evaporate the water, collect the gross sludge that's left over, and pack it into a special, labeled bucket for the professionals to come pick up.
And here's what that setup actually looks like. It's pretty clever, really. You line a beaker with plastic and just let the water evaporate, ideally in a fume hood. It's a simple but really effective way to cut down on the amount of liquid waste that has to be hauled away.
So we've talked about crazy costs, hidden dangers, and complicated procedures. But it turns out preventing the biggest problems all boils down to one incredibly simple, absolutely critical rule.
Just look at these labels. They're done right. A good label isn't just the chemical's name. You absolutely have to include its concentration and a quick summary what the main hazards are. Is it flammable? Is it toxic? That's the info that keeps everybody safe.
And this right here is the big takeaway from all of this. If you walk away with just one thing, let it be this. Always label everything. Every single beaker, every flask, even that temporary solution you just mixed up. That one simple action keeps something from becoming an unknown
And we already know that's the most dangerous and expensive problem you can have.
And you know, this rule doesn't just stop at the lab door. It kind of makes you think, doesn't it? What old, unlabeled cans of paint or bottles of weird cleaning chemicals are lurking in your own garage or under your kitchen sink? Every single one is a little mystery box, a potential hazard that could have been avoided with just one simple action: putting a label on it.